Write down the next topic. చాలా ముందు చేసినారు. Okay, listen. So what was the formula we have learned in heat energy? The thermal properties of matter. Q is equals to ms or mc delta T, right now? So Q is equals to mc delta T. So in this chapter, like we are talking about the thermodynamics, no, like about gas we will talk. Okay, so this specific heat, no, like we will talk in terms of molar specific heat or gram specific heat. Write down the first point. Gram specific heat capacity. Gram specific heat capacity. Specific heat capacity. So in this, no, gram specific heat capacity will calculate in terms of gram or kilogram. And the second point is molar specific heat capacity. So in this we will calculate in terms of moles. So these are the two terms which we are going to use in today's class. So you have learned about this Cp and Cv in chemistry, right? And what is the formula for N? N is equals to m by capital M, like given mass by molecular weight. Suppose for example 10 gram of oxygen, what is the number of moles? 10 by 32. Okay, write down. N is equals to small m by capital M. The next point is N is equals to small m by capital M. Small m is the mass of the gas and capital M is the molecular weight. So for example, if we take 10 gram of oxygen, okay, then N will be equals to 10 by 32, which is nothing but 5 by 16. Take down. So like what are the two ways of measuring the work done we have seen in this lesson? Open, refer. One is pressure and one is volume, right? So if a constant pressure is there, like work done will be 0. If constant pressure is there, work done will be 0. If constant volume is there, okay. Similarly, like the two terms which will involve in this heat energy also, constant pressure and constant volume. Right on the next point. we can calculate the heat of the gas by two ways. So one is keeping the pressure constant, volume changing. Keeping the pressure as constant and volume I can change it. The second way is keeping the volume constant, I can change the pressure. Okay, and if you notice this small c or capital C in questions, no, small c is for the gram specific heat, okay, capital C is for molar specific heat, okay. Sometimes like the formula will be like Q is equals to mc delta T, okay. Sometimes the formula will be Q is equals to nc delta T, okay. So n is nothing but number of moles and capital C is nothing but molar specific heat capacity. So whenever I am using n, I should second one is gram specific heat at constant volume. Third one is molar specific heat at constant pressure. and fourth one is molar specific heat at constant volume. Write down next subheading. If heat is supplied, if heat is supplied at constant pressure, if heat is supplied at constant pressure, so two formulas, mCp delta T and ncp delta T. So one is for gram specific heat and one is for molar specific heat. So whenever I am mentioning N, it is molar specific heat. Whenever I am mentioning the value M, it is gram specific heat. Next one is if heat supplied at constant volume, if heat supplied at constant volume. So Q will be equals to mCV delta T and Q will be equals to ncV delta T. Right on next point. The relation between Cp and Cv, Cp and Cv. So what is the relation? Okay. Cp minus Cv is equals to R. What is R? Gravitational constant. Right on. Universal gas constant. Cp minus Cv is equals to R. So R is universal gas constant. The value is 8.314. So what is the SI unit? Joules per mole Kelvin. Joules per mole Kelvin. SI unit of R is joules per mole Kelvin. So what is the other formula? Cp minus Cv is equals to small r, which is nothing but R by M. Right down. So this formula we'll use in terms of grams. So most of the cases we'll use this formula only. Cp minus Cv is equals to R. Okay. Small r is nothing but specific gas constant, specific gas constant, specific gas constant. So what is the other relation, like in terms of gamma? Cp by Cv is equals to gamma. Cp by Cv is equals to gamma. Like gamma, like adiabatic constant. Write down the next one. Cv is equals to R by capital R by gamma minus 1. Cv is equals to capital R by gamma minus 1. Cp is equals to gamma times R by gamma minus 1. So if I take the ratio of both of them, will I get gamma? Cp by Cv. So this and this will get cancelled off and remaining will be gamma. Okay. Write down the next point. Gas in terms of mixture. Gas in terms of mixtures. So Cv mixture and Cp mixture. So Cv mixture is equals to N1 Cv1 plus N2 Cv2, N1 Cv1 plus N2 Cv2 up to Nn Cv n by N1 plus N2 plus up to Nn. Similarly for Cp mixture also, N1 Cp1 plus up to Nn Cpn by N1 plus N2 plus and so on. The next one is gamma mixture. So what is the formula for gamma? So Cp mixture by Cv mixture. Completed. Next subheading, degree of freedom. Degree of freedom. Degree of freedom in Cp and Cv. In bracket you can write Cp and Cv. So what is the meaning of degree of freedom in terms of gas? Okay, 3, 5, 7, that one okay, but I am asking the basic term. What is the meaning of degree of freedom? So what is the meaning of freedom first of all? So there is no any restriction for the gas molecules also. Okay, so degree of freedom is nothing but like in terms of gas we are talking means like there is no restriction for gas particles to move around in a space, either in x direction, y direction or z direction, or in the rotational motion. Okay, write down. It is the randomness of the particle. It is the randomness of the particle. Next point, in terms of motion, in terms of motion, in terms of motion, the first one is translational motion. First one is translational motion. Second one is rotational motion. And the third one is vibrational motion. Okay, three things we will talk here. So the next point, monoatomic gas. Monoatomic gas. Hyphen degree of freedom. Degree of freedom is equals to 3. Monoatomic gas, keep a hyphen, the degree of freedom is equals to 3. The next one, diatomic gas. Diatomic gas. So degree of freedom is 5. So in this 5 now 3 translational, 2 rotational. Okay, you can write in that 5, 3 is translational, 2 is rotational. Okay, next one is vibrational motion. Vibrational motion. So in this we will talk about the triatomic gas. Okay, monoatomic, diatomic, next one is triatomic. So in this triatomic, no, 2 types. The first one, linear, and the second one is non-linear. Triatomic gas, the subdivisions are linear, non-linear. So for linear, degree of freedom is 6. For linear, degree of freedom is 6. For non-linear, degree of freedom is 7. Example for linear, CO2. CO2. An example for non-linear, H2O. H2O. So like how you will write the bond between CO2 and H2O? C double bond O. Like I will draw the diagram and let me know is that correct or not. Okay, C double bond, here also double bond O, and H, should I do like this or like this? Which one is correct for H2O? Huh? Huh? Rendu wrong. Then tell which one is correct. O single bond H. Draw. Draw. So for CO2 it's correct, na? What about H2O? Draw it. So it won't be like this, no? It will be like this, na? So whenever you are getting in this terms, no, this will be non-linear, and in a straight line it will be a linear. Okay. So in linear, no, it will be 3 translational, 3 rotational. 3 translational, 3 rotational. Okay. So for the triatomic gas, note point, if they have not mentioned anything in the equation, take F is equals to 6. If they have not mentioned anything in the equation, take F is equals to 6. Okay. Write down next subheading, Cp and Cv in KTG. Cp and Cv in KTG. Write down Cp is equals to F by 2 into R. F is nothing but degree of freedom. Cp is equals to 1 times of 1 plus F by 2 times R. Or you can take down a simple formula, Cp is equals to R times 1 plus F by 2. So Cp by Cv is equals to, you can take this ratio, F by 2 times of R and R times 1 plus F by 2. So what is Cp? R times 1 plus F by 2, and Cv is F by 2 into R. Okay. If they are asking ratio in terms of KTG, no, like degree of freedom, you can use this formula. So other formula for Cp by Cv is gamma. మంచిది. E is equals to 3 by 2 K times T. So have you seen this formula before? Where we have write? Monna sir. Write down. What is K? Boltzmann constant. Yes. Yes. K is Boltzmann constant. So what is E? Energy. Write down the other formula for E in terms of degree of freedom. E is equals to n, small n, F RT by 2. N F RT by 2. This is the other formula for E. Write on the next topic. monoatomic gas, diatomic gas and triatomic gas. Monoatomic gas, diatomic gas and triatomic gas in terms of Cp, Cv, in terms of Cp and Cv, as well as gamma, as well as gamma. Okay, now draw in a tabular column. Cp, Cv and gamma. What is gamma? Cp by Cv. Okay. Okay, topic L, right. So monoatomic. So what is the degree of freedom? So for diatomic. So for triatomic. So F is equals to 6, F is equals to 7. For this is linear, this is non-linear. Now calculate and tell me the answer for Cp, Cv and gamma. Calculate. Cp formula I have given, no, and Cv formula I have given, no. In terms of R only you can say. No need to calculate in decimal also, you can keep in fraction. You can keep in fraction itself. So Cv is equals to Fr by 2, Cp is equals to R times 1 plus R by 2, F by 2. So in terms of like in place of F I need to substitute the value of 3, 5, 6 and 7. Get it? 3 by 2. This is 3 by 2. Okay, Cv is 3 by 2 R and this is 5 by 2 R and this is 3 R and this is 7 by 2 R. What about Cv? 5 by 2. 5 by 2? 3 by 2. How 3 by 2 will come for Cp? 5 by 2R and this is 7 by 2. Right, calculate, no? Fast. 7 by 2R. What about the last two? 4R and this is 9 by 2R. Cross verify it now, fast. One 1.6. Second one 1.4. Third one and third one like 2 are there, no? 1.33. Okay. And the last one is 1.2. So if they are asking any order of the monoatomic, diatomic and triatomic, what will be the order? Descending order. What is the meaning of descending order? So highest to lowest. So in descending order means monoatomic, diatomic and then triatomic will come. Okay. Ascending, the reverse manner, the vice versa. Completed? Okay. So write down next topic. Thermodynamic process. Thermodynamic process. So under this, the first one is isobaric process. Isobaric process. So thermodynamic processes are like isobaric, isochoric. What is the other name of isochoric? Other name of isochoric? Isometric. Okay. So first one is isobaric process. Second one is isochoric process. Third one is adiabatic process. Isothermal process. So what is isobaric? Pressure will be constant. What is isochoric? Volume is constant. Isothermal? Temperature is constant. Adiabatic? There is no heat exchange between the system and the surroundings. Okay, write down. The first one is isobaric process. Keep a hyphen. It is nothing but constant pressure. At constant pressure, the gas will be heated off. Okay. Isochoric or isometric process is nothing but volume is constant. Isothermal process is temperature is constant. Temperature is constant. And the fourth one is adiabatic process. There is no heat exchange. Topic is isobaric process. So pressure will be constant. The first point is pressure will be constant. So for the heat, no, the formula will be QP will be equals to mCp delta T. mCp delta T. So here work done will be 0 or not 0 if pressure is constant? It will not be equals to 0. Then what will be the formula for work done in terms of pressure and volume? PV. So W will be equals to P times of V2 minus V1. So according to first law of thermodynamics, so what is the first law of thermodynamics is? Q is equals to U plus W, no? So delta Q P is equals to delta U plus, what is W here? P into V2 minus V1, and the QP, the value I know, MCP delta T. Okay. Next point is, according to ideal gas equation, what is the equation? PV is equals to nRT. What are the things are constant here? N and R are constant, right? If I take this as a constant, and what about the isobaric process? Pressure is constant. P also constant. So V is directly proportional to T. So V1 by V2 will be equals to T1 by T2. The next point is graph. So the PV graph will be looking like this. V1, V2. So your pressure is constant or it is varying? It is constant. So sometimes the graph will be looking like this also. V and this is P, V2, V1. So what first graph is telling? Pressure is constant, volume is changing. How it is changing? So it is increasing or decreasing? What about the second graph? So here volume is increasing, here volume is decreasing. So whenever you are looking into the graph, look the axis whatever they have given. Okay, then decide whether it is isobaric process or isochoric process. The next point is completed. So what will be the slope of the graph? Slope of the graph. Pressure volume. 0 is the graph. 0 will be the slope. See, if the angle is obtuse angle, it is negative. It is acute angle means positive. Acute below 90 degree, it is positive. Above 90 degree, negative. Exactly, it is perpendicular to the x-axis, it is infinite. When it is parallel to x-axis, it is 0. 4 things: obtuse angle negative, acute angle positive, and then perpendicular to x-axis infinite, and parallel to x-axis 0. Okay, if you remember the 4 things, no, graph is easy, that's it. Okay, now you tell. Like if I reverse this, no, it will be x and this will be y, no. Which one infinite? Second one. Both are 0 only. Slope of the graph will be 0 according to the P I am calculating. If I need to calculate for this one, I will take the graph with respect to x-axis. If I need to calculate for this one, I will take the graph with respect to y-axis. So if I take it is parallel, no. So for both of them it is 0. That's why I have given the both graphs. So don't get confused. Anduku 0 avutundi, induku ella infinite avutadi. Huh? Completed? So any doubt in the first process? So we have talked about the work done also, we have talked about the first law of thermodynamics also, and we have talked about the graphs. Okay. The second one, isochoric or isometric process. Isochoric or isometric process. So whatever we have talked, we will talk similarly here. The first one, what is the formula? QV is equals to mcv delta T. Okay, fine. The next one, what we have talked? Work done. Since V is equals to constant, work done will be equals to, this constant, no? Constant, W will be equals to 0. So according to first law of thermodynamics, delta Q will be equals to delta U. Since W is 0, no? U plus W is the formula, no? So since W is 0, Q will be equals to U. So whatever the heat I am talking, I will talk about the energy also, both are same. So the graph will be looking like this. So this is my pressure and this is my volume. So constant volume, this is my P1 and this is my P2. And when I talk about this is my volume and this is my pressure, P1, P2. Take down. And according to the equation, no, ideal gas equation, PV is equals to nRT, V is constant, nR is a constant, P is directly proportional to T. So P1 by P2 will be equals to T1 by T2. Okay, this is according to the ideal gas equation. Okay, what is the slope of the graph now? It is infinite. Perpendicular, no? Write down. See, for pressure it is 0, like for volume it is infinite. And you have talked about so for both adiabatic as well as isothermal, the graph will be looking similar, but how you will differentiate the both graphs? Add. Tell. ఐసోథర్మల్ అంటే టచ్ అయి వస్తుంది. నో, టచ్ కాకుండా వస్తుంది. ఐల్ టెల్ isothermal. The next topic is isothermal. So in this, what is the constant? Temperature is constant. So if T is constant, no, according to the equation, ideal gas equation, PV is equals to constant, right? No? Yes or no? According to ideal gas equation, PV is equals to nRT. Since nR is constant and T is also constant, the total term is constant. So PV is equals to constant. So P1 by V1, I mean P1 by P2 will be equals to V2 by V1. Can I say P is inversely proportional to V? Yes, no? So P1 by P2 will be equals to V2 by V1. Write down next point. So delta T will be equals to 0, no? Delta T will be equals to 0. Temperature is 0, no? Since there is no temperature, internal energy also 0. So since delta T is equals to 0, delta U also will be equals to 0. So according to first law of thermodynamics, delta Q will be equals to delta W. And you can take the page number 118, and work done is nothing but 2.303 nRT log V2 by V1. Page number 118. You can write that to work done formula. Page number 118, right side top corner. Isothermal process. Right. So if it is V2 by V1, then in terms of P, P1 by P2. Okay. So the graph will be looking like this. For the isothermal, it is a curve. So if I mention the arrow mark like this, what is it denotes? Pressure decreases. So in terms of volume, pressure decreases, volume increases. Yes, because it is inversely proportional. Both are. Yes or no? Can I say this is a expansion because volume is increasing? No. Oh, this is V1, this is V2. So V1 to V2 it is going, no? So since it is increasing, I can say it is a expansion. Suppose the arrow mark in the opposite direction. Pressure increases, volume decreases, and it is compression. take down. Completed? So what will be the slope here? Positive slope or negative slope? Take a point, draw a tangent, draw the x-axis, draw the angle, check whether it is obtuse or acute, and you can check that is a positive or negative. Negative. So slope is negative. Right? Obtuse, no? So if I take a point here, if I draw a tangent, if I take the angle, it is obtuse. So I will get a negative angle. So slope is negative. Write down next one. Adiabatic process, the final one. Adiabatic process. So in this there is no heat exchange, no? So Q will be equals to 0. Write down. There is no heat exchange. Q will be equals to 0. Q will be equals to 0. Then according to first law of thermodynamics, delta U will be equals to minus W. This is the equation, no? Delta Q is equals to delta U plus delta W. Since this is 0, no? 0 will be equals to delta U plus delta W. So U will be equals to minus W, no? Write down. So in terms of ideal gas equation, PV is equals to nRT, but the equation will be PV power gamma is equals to constant. So where gamma is adiabatic constant. So can I say like P1 V1 power gamma equals to P2 V2 power gamma. So if I want in terms of temperature, then how can I measure? This equation we know, and PV is equals to nRT. nR is constant, I can neglect this one. So PV is equals to T. So V will be equals to T by P. Right now? So if I want in terms of P and T, I can take this one, no, in terms of V. So P T by P power gamma will be equals to constant. Getting the point? Understood? If I want in terms of volume and temperature, then P will be equals to T by V, then T by V into V power gamma will be equals to constant. So T V power minus 1 V power gamma will be equals to constant. So T will be, T into V power gamma minus 1 will be equals to constant. So this is in terms of temperature and volume. And what about this one? P T power gamma P power gamma is equals to constant, and if I expand this one, P power minus gamma T power gamma will be equals to constant, then P power 1 minus gamma T power gamma will be equals to constant. This is in terms of pressure and temperature, this is in terms of temperature and volume, and this is in terms of pressure and volume. Take down. PV is equals to nRT and PV power gamma is equals to constant. So from this two equation only we have got these equations. Okay. Remaining terms everything like only calculation part and substitutions. Gamma times of slope of isothermal process. Isothermal process. Okay. So both the curves will be looking similar to each other, but how to identify the curves means like adiabatic process will be more steeper than isothermal process. Steeper in the sense it will be having more bend. Okay, if I draw two curves like this, so this one will be my adiabatic and this one will be my isothermal. Okay, the steeper, how much curve it bent, that one will be adiabatic, and the less steeper will be isothermal. Okay, you can take the page number 119 and the right side top, the four curves they have given, no, like four, which is parallel, perpendicular and two curves. Okay, if you look into that, can you get the steeper curve is adiabatic and less steeper is isothermal? and which is perpendicular is isochoric, and which is parallel is isobaric. Okay, you can write the next one. Work done is equals to, work done is equals to, so the same page number, the left side top, the first formula, W is equals to NR by 1 minus gamma times T2 minus T1. T1 minus T2 they have given, no. Now in terms of pressure and volume, in terms of pressure and volume, so temperature, no, is directly proportional to PV, no. So T1 in the sense P1 V1, T2 in the sense P2 V2. Write down. P1 V1 minus P2 V2, but one, like they have given that NR by gamma minus 1, no, but that is NR by 1 minus gamma for pressure and volume. So they have given W is equals to NR by gamma minus 1 T1 minus T2, but in terms of pressure and volume, work done will be NR by 1 minus gamma times P1 V1 minus P2 V2. Okay, write down.